using high tensile steel wires of diameter 5 mm or 7 mm diameter. So, in the Magnel-Blaton system, steel wire having diameter 5 mm or 7 mm are used up to even number 64, up to 64. These wires are arranged 4 in a group in a horizontal line. Vertical and horizontal spacer are provided at a rate of nearly 1.5 meter center to center to keep the wire in correct position. So, in Magnel-Blaton system, vertical spacer and horizontal spacer are used. This is the vertical spacer, this is the horizontal spacer, and these consist 4 holes. So, in one hole there is 2 wire. The wire are anchored by wedging 2 at a time into a sandwich plate. The sandwich plate or locking plate are about 25 mm thick and are provided with 2 trapezoidal groove in the upper surface and 2 in the lower surface. So, locking plate is a trapezoidal consists a trapezoidal groove. So, this consists 4 in upper 1, 2, 3, 4. So, 2 bar in one groove. So, this is the locking plate sandwich plate. The wire taken to 2 in each groove and tightened, then the steel wedge is driven inside the groove. When the two wire each in one in this groove, one in this groove, then the steel wedge plate is driven into. After tightening the cable, then the steel wedge plate is driven in this sandwich plate. Then the steel wedge is driven inside the groove. Each plate can anchor 8 wires. A complete anchorage unit may consist 1 to 8 sandwich plate. The various sandwich plate are arranged one above the other against the distribution placed. Regular duct are cast at a suitable place along the length of member by introducing the rubber core in a mold. The rubber core are pulled out after 6 to 8 hours of concreting. Duct are thus formed. The wire are introduced in these duct only at the time of pre-stressing. So, in this method, duct formed by pulling out the rubber core. There is no need to use a metal sheather. Therefore, this method Magnel and Blaton method system is economical. So, duct are formed, the wire are introduced in these duct only at the time of pre-stressing. Thus, Magnel-Blaton system result in saving the cost of sheathing used in Freyssinet system. So, the Magnel-Blaton system is economical as compared to the Freyssinet system, because in Magnel-Blaton system metal sheather are not used. Third system of pre-stressing is Lee-McCall system or stress steel system or bar system. This method is simple one, easiest one. So, Lee-McCall third system of pre-stressing, Lee-McCall system. This system is very simple. In this system, instead of wire, high tensile steel rod varying from 12 mm to 28 mm diameter as tendon are used. The rod are threaded at their end. The rod consists thread at its end. So, in this system, high tensile steel bar are used. The diameter of bar are ranging from 12 to 28 mm. So, in this figure, this is the concrete member, these are the end plate, this is the washer and nut, and these are the thread on end of the bar. Hole are made by mean of rubber core when the concrete has set. Rod are introduced in the hole after removing the core. After the desired stretching, a nut is tightened at its end uh, to prevent its return to original length. In this system, rubber rubber core is provided while concreting. When concrete get hardened, remove the rubber core that form a duct. Then steel bar are passed through these duct. The steel bar are having thread at end. After stretching, a nut is tightened. In this system, the member can be stressed and unstressed as desired. Thus, the early losses due to shrinkage and creep of concrete can be made good by restressing the rod. This system is useful for 12 meter to 15 meter. Lee-McCall system is suitable for span from 12 meter to 15 meter. Lee-McCall system is also known as a bar system because in this system steel bar used. So, therefore, this system is also called as a bar system. The disadvantage of using wire are. So, in Lee-McCall system, we use steel rod or steel bar, and we are not using the steel wire. If we use steel wire in Lee-McCall system, the following disadvantages are there. Possible corrosion, first disadvantage is possible corrosion, which would reduce the effective in the case of wire than in bar. In Lee-McCall system, if wire are used, then there are chances of corrosions. Second, possible unequal stressing of wire. Wire cannot stretched equally. Third disadvantage of using wire in Lee-McCall system, loss of some stresses in steel due to the inevitable slips that occur when the jack is released as the anchorage adopted for the use of wire is relied on the wedges action. So, chances of slipping over is more in wire as compared to steel bar. So, therefore, we use steel bar in Lee-McCall system instead of wire. Fourth disadvantage, stressing cannot be done in stage in this system by tightening the nut at any stage. So, stress cannot apply at any stage. However, bar system has certain disadvantages also. There are other disadvantages of Lee-McCall system or bar system are there. First one, large sized bar cannot be used in all member. So, all member does not require large size bar. So, first disadvantage which is other than using the wire. So, large sized bar cannot be used in all member because all member does not require large sized bar. Second, high pre-stressing intensity cannot be employed. So, in Lee-McCall system, high pre-stressing intensity cannot be employed. Third, jack have to be of large size. So, jack required for bar system because bar is of bar having a larger diameter. Therefore, jack required for bar system should be of large size. Next topic is loss of pre-stress. The pre-stressing force applied to the member does not remain constant, but it decreases with the passage of time. The amount of pre-stressing force which get reduced with the passage of time is known as loss of pre-stress. So, with the passage of time, pre-stressing force decrease due to various reasons. These decrease in pre-stressing force is known as loss of pre-stress. The loss of pre-stress may vary 15 to 20% of the initial pre-stressing force. So, the loss of pre-stress is ranging from 15 to 20%. So, causes of loss of pre-stress. First one is lost due to the elastic shortening of concrete. Due to elastic shortening of concrete, there is loss of pre-stress, and it may be from 3% to 6%, and that loss is called loss due to elastic shortening of concrete. Second, loss due to creep of concrete. The decrease in pre-stressing applied force, the pre-stressing force due to creep in concrete is called loss due to creep of concrete. Third, the loss due to shrinkage of concrete. Shrinkage means contraction, decrease in size of concrete. So, shrinkage is a contraction of concrete, but the contraction due to the contraction of concrete, there is loss of pre-stress. There is loss of pre-stress due to shrinkage of concrete. This loss is called loss due to shrinkage of concrete. So, these are three. Next loss, loss due to relaxation of steel. After passage of time, after some time, the steel relaxed, and the loss of pre-stress due to the relaxation of steel is known as loss of pre-stress due to the relaxation of steel. Fifth loss of stress, pre-stress, is loss of due to the friction. So, in pre-stress method, in pre-stress system, the cable, the tendon or cable wire or wire strand is passed through the duct in the concrete. So, the friction between the wire and duct causes loss, and that loss, that is due to the friction, is called loss of pre-stress, loss in pre-stress due to friction. Last one is loss due to the slippage of tendon and anchorage system. So, and last loss of pre-stress due to slipping over of tendon and anchorage system is known as loss due to the slippage of tendon and anchorage system. So, dear student, this is the all about the concept of pre-stressing of concrete. Thanks.